Today we are going to talk about Lesson 2 for Unit 1, Matter and Energy in 4th grade, which is called Forces in Space. Don't forget that whatever is highlighted here on the screen in yellow, you should be highlighting in your student reader. Running in space. Sunita Williams is an astronaut who has lived on the International Space Station. She was the first person to run the Boston Marathon from space. It took her 4 hours, 23 minutes, and 10 seconds to run the 42-kilometer or 26.2-mile race. There are some challenges to running in space. One challenge is that there is much less gravity on the space station than there is on Earth. Gravity is a force of attraction between all matter. On Earth, the force of gravity pulls all objects near Earth's surface downward. A force is a push or pull that acts on an object, changing its speed, direction, or shape. Earth's gravity keeps you from floating off into space. It's also why things thrown in the air fall back to the ground. In the space station, there is much less gravity than on Earth. As a result, Sunita had to attach herself to the treadmill, with bungee cords. Without the bungee cords, she would float. All matter has gravity, even the matter that makes up people. The reason a person doesn't noticeably attract nearby objects is because more massive objects have more gravity. Earth's gravity pulls on all objects on or near Earth's surface because Earth is so massive. The gravitational force exerted on an object by a planet or moon is called weight. It is measured in newtons. Here on Earth, weight is calculated by multiplying the object's mass by the force of Earth's gravity. The pull of gravity is nearly identical everywhere on Earth. Non-scientists often think that an object's weight is the same as its mass. The two are related because an object's weight depends on its mass. However, weight also depends on the force of gravity. When astronauts travel to the moon, their mass doesn't change, but their weight does. This is because the moon is much less massive than Earth is. As a result, its gravitational force isn't as strong as Earth's. Forces cause movement. When you stand on Earth's surface, gravity pulls you down toward the center of the Earth. In reaction, the ground has its own force that pushes back up with the same amount of force. This keeps you from sinking into the ground. When the forces acting on an object are equal, they are balanced. If the ground did not push back with the same amount of force, you would fall into the ground. In this case, the forces would be unbalanced. Gravity would pull you down with a greater force than the force of the ground pushing back up. When all of the forces acting on an object are balanced, the object will not change its motion. If you want to move, there has to be an unbalanced force acting on you. This is because all events, including motion, require a cause. Unbalanced forces cause motion. As Sunita ran the marathon, she and everyone else on the space station traveled around Earth twice. This is because the International Space Station is in constant motion around Earth. The space station orbits Earth once every 90 minutes. To orbit means to travel in a circle around an object. The space station orbits Earth because Earth's gravity pulls on it. This pull provides an unbalanced force that causes the space station to move. Gravity is the force that causes all movement in the solar system. The strength of gravity's pull depends on the mass of the objects and the distance between them. For example, the Sun is the most massive object in our solar system. More than 1 million Earths could fit inside the Sun. Because of its mass, the Sun's gravity pulls on Earth, keeping it in orbit around it. It takes Earth about 365 days to orbit the Sun, which we call 1 Earth year. There are billions of stars in the universe just as massive as our Sun. However, these stars are very far away from our solar system. This is why we don't feel their gravity. Our Sun seems so large and bright to us because it is so much closer to Earth than any other star. Patterns in space. Even though the sun is much closer than any other star, it is still very far away. This is why Earth's gravity holds you on Earth. The pull of Earth's gravity also keeps the space station and our moon in orbit around it. The moon takes about 29.5 days to orbit Earth. This equals 1 Earth month. These predictable motions cause patterns that we can see from Earth. Astronauts can also see patterns from space. For example, as the space station orbits Earth every 90 minutes, astronauts see the sun rise and set about 15 times every day. In contrast, here on Earth, we see the sun rise once in the morning and set once at night. This happens because Earth rotates on an imaginary line that goes from the North Pole to the South Pole. This imaginary line is called an axis. As Earth rotates, part of the planet gets light and then dark. The sun always shines, but its light only hits 1/2 of Earth at a time. This is why we have day and night, as well as sunrises and sunsets. Low gravity in space. Even though Earth's gravity keeps the space station in orbit, there is much less gravity on the space station than on Earth. Low gravity explains why astronauts lose muscle mass when they are on the International Space Station. On Earth, we have to use our muscles just to stand up against the downward pull of gravity. This requires our bodies to maintain enough muscle to support their own weight. In the low gravity environment of space, astronauts lose muscle since it is not required to support their weight. To counter this, astronauts have to exercise regularly. Sanita trained at least 4 times each week for months to prepare for the marathon. Make sure you check out the 4.1.2, Unit 1, Lesson 2, review question video next.